All right, so welcome to the recording for the Unit 5 lab. We are almost there, 2 labs left. So again, walk you through where to get everything, starting with the website. So if you go to Unit 5 in this class content area, you can get it from here, 5.07, types of chemical reactions, or you can get it from the plan. And this was something in February. 5.07, right here. All right, so this one, I don't have the link in here yet to where this video will go, but it's actually going to fall right in between laboratory and investigation. But lesson introduction will have a materials list for you, some basic information, maybe some questions to answer as you read through laboratory types of chemical reactions. You definitely want to have done everything else in Unit 5 before you start this one, so you're familiar with what a double displacement reaction is, what a combustion reaction is, single displacement, stuff like that. Then the investigation, this is where you're going to have that link to the virtual lab, which is not solely allowed as your option for doing here. You can kind of get an idea. This virtual lab is quite different, especially part 1, than what we're actually doing in the hands-on lab. So definitely you want to make sure you're doing the hands-on lab stuff. For the most part, everything you need is in the kit. The only other thing that you kind of have to supply is a little bit of foil. It calls for some spoons. I don't really know why. You can do this with the Scoopula, so don't worry about the spoon, the plastic spoons. You will need some water. But the lab report is going to be under this Dropbox. Remember, this is where you're going to turn in those pictures with the recording or the incredibly detailed description of what went well and what didn't as far as your proof of hands-on work. But let's go grab the lab report. Alrighty. So go ahead and make sure you have that open and available on your computer. Close this calendar. All right. I'm just clicking enable editing here. We will come back to these questions towards the end. But what I want you to do is switch over to my visual area so we can go over some of the materials that you need. So for part 1, you need Scoopula. All right, we're going to use this instead of the plastic spoons. I'm not entirely sure why they say plastic spoon. Stirring rod. Okay, we're going to wash this in between scoops, or in between stirs. That way there's no contamination. Yeah. Graduated cylinder here. That's to measure our ammonia later. The big beaker in your kit, 250 milliliters. And chemical-wise, there should be a slightly larger dropper that says household ammonia. You're going to want that one. Let me get the plastic cut off of here. Oh, and speaking of which, I should have my goggles and my gloves on. Okay, I haven't opened any of the chemicals yet. Let me get my gloves out of the plastic wrap. And then there are 2 solids that you need for the first part of this lab. The first one is called alum, A-L-U-M. It's essentially aluminum. Okay. It's aluminum sulfate and something. All right. And then the magnesium sulfate, right there. Alrighty. So, part 2, you're going to need a well plate. I've already put in some of the things. So this was foil from the house. This, in your kit, there's a larger amount of copper wire, like a spool of it, or kind of like several rings of it. I just cut a little bit of that off, because you're going to need the rest of that, and you're going to need a decent amount of it for a lab in Chemistry B. But I just took a little bit off of that for this part of the lab. And then you need zinc powder. All right, and those are going to go in the other 2 wells, but we'll do that when we get there. You're also going to need copper sulfate, 0.1 molar. This is a slightly larger dropper bottle, and it does have a blue tint to it. And silver nitrate, 0.1 molar. And this is a even bigger bottle than the copper sulfate. All right, and again, silver nitrate, so the bottle's not see-through, it's actually solid white. And then for part 3, just so that we have all of our materials, we're going to need the well plate again. You're going to still need that silver nitrate and the copper sulfate, but we also are going to need sodium chloride, 0.1 molar. We're going to need sodium phosphate, right? So the book says diabasic sodium phosphate. The container says in big sodium phosphate, but if you read really, really tiny towards the bottom, it does say sodium phosphate diabasic. That way we know we have the right thing. And you're going to need 0.1 molar sodium hydroxide. All right, so this is a little bit of a bigger one. You're also going to need this for the Unit 6 lab, so don't use this all up. All right, so let me get my stuff back organized here. Starting with part 1. So you are going to want to make note of any chemical reactions that you see. And I'm just going to walk you through the first part of part 1 so that you see how it's done, and then you get to do the second part on your own. So first things first, we need 125 milliliter beaker of water. Tap water is fine on this one. So, and then just get as close to 125 as you can. It's not actually quite marked on there. So if you end up being a little bit off because you have to go in between 2 lines to get that, it will be okay. But get close to 125 milliliters. We have a little bit extra, that's fine, because we need the water to dissolve the solids. So it says add 2 grams of alum to the water and stir with a plastic spoon to dissolve the alum. This may take a moment or 2 of stirring. Record your observations. So the alum, if you look at the container, my container says that it's 2 grams. I'm going to assume. Which is probably not the right thing to do, but I don't have my scale with me today. So I can't double check it, nor do the lab instructions tell you to. So I'm gonna hope that our friendly lab kit creators in K-12 headquarters actually measured this out for me. So I'm just gonna dump it in. And that means I'm not gonna be able to do this again. So 2 grams of alum to the water. Oh, that's what you're stirring. That's what the plastic spoon's for. We'll just use the plastic stirring one. I don't think that'll make too big of a difference. Might take a little bit longer. That won't be the end of the world. So we're going to stir this until it dissolves. So it might take a while. I didn't do this intentionally, but I did kind of use warmish water out of the faucet, which is going to help with dissolving. It's going. There's still some down there, though. Almost done. So, did the alum disappear? what kind of change is this? Do some review back to Unit 1. So dissolving means that the ions have separated and they are being pulled apart, or kind of like in between each of the ions is a water molecule. So you actually haven't lost any of the solid. It's just broken up so tiny that we can't see it. If I were to allow this to evaporate overnight, and evaporation is a physical change, we would get that alum back. So this was a physical change. What we're going to do next, we hope, will cause a chemical change, and we'll get signs of a chemical reaction. So I rinsed off my stirring rod. Then it says, stir in 10 milliliters of ammonia, record your observations. Safety note, ammonia has strong fumes, do not breathe the fumes. So, with the ammonia, don't breathe it in. It's smelly. And this is going to take a little while to get 10 milliliters because it's a little squeeze bottle. And I actually might go slightly under 10 milliliters. I think I'm going to add 9 just to make sure that I have at least that much the next time, in case our people at the K-12 headquarters didn't exactly get milliliters in here. Or sorry, 20 milliliters total in the bottle. I don't want to run out and not have anywhere near enough for part 2. Alright, there's about 9. Looks like about half the bottle's left, so that's good. I should definitely have enough for part 2. Since we aren't going for a stoichiometry or something here, using a little bit less than what it says isn't going to hurt anything, and we should still be able to see a reaction. So, stir in 10 milliliters of ammonia and record your observations. So, here we go. You can already kind of see something happening. A precipitate is forming. You can kind of see some strings. So we got a color change here, and as it was forming, you can kind of tell that it was a solid, but we formed a precipitate. Okay, you can see that we went from clear to kind of this milky color. So you're going to repeat this procedure with 125 milliliters of water, but with the other solid, the magnesium sulfate. Then you're going to add the ammonia and record what you see there. Sorry about the squeaky faucet there. Now, to do that, you are going to have to clean up your beaker. So, it's fine to dump this down the drain. Just make sure you dump it down the drain with lots and lots and lots of water. And rinse out your beaker completely. Okay, so that's part 1. You're going to do the second reaction in part 1. So now we're going to move on to part 2. So part 2 is single displacement reactions. So this one we have 4 metals. I have 2 of the metals already in here, the aluminum and the copper. So the aluminum foil. Then you have zinc, powdered zinc in a container here. I'm going to take the scoopula and scoop some of that zinc into the other 2 wells. All right. Now you should get some good reactions out of this. I think if I recall correctly, only one doesn't react. So zinc's a little messy, just because it's kind of sticks to the plastic. Try really carefully not to get it into the other wells. Okay, if you want to, take a picture of what these look like before you add the chemicals. All right. because any sort of color change, something like that, is going to be what you're looking for. If the gasket's given off, okay, we're not going to get a precipitate here because we're not starting from two liquids. But we'll keep going until we get a reaction. So it says, don't be aluminum foil on the ball, so it fits in the microplate well. I just kind of cut it in little pieces. Add approximately 25 drops of each solution listed in table 1 into the specified well. So, copper sulfate and silver nitrate. So let's do the copper sulfate with the zinc and the aluminum first. If we get any reactions, then we'll talk. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I don't think I even need 20 for you to be able to tell what's going on there. If you look, the zinc floating on the top that hasn't really sunken in yet is still silver, but the stuff sunken down on the bottom turned black. All right, so we had a color change, which means chemical reaction. Okay, so go ahead and continue with the rest of those. So that you can see if you get any more reactions. I don't want to give them all away. So that's part 2. And I'm actually going to continue using this well plate as we go on to part 3. Alright, so part 3, this one's a lot like the last lab that we did. You're taking 2 liquids, combining them together till you get to see if you get any sort of reaction. Okay, so let's see. The procedure says to use 25 drops. We were using 10 drops in the last lab, especially since I know we need the sodium hydroxide for the next lab. I'm going to do 10 drops of each just to conserve it, okay? But our first one, we'll keep going on these until we get a reaction. And I'm actually not going to do this in row A, I'll do this in row C. But I've got sodium chloride, so 10 drops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And actually, you can do this like what we've done before. I'm also going to put sodium chloride in 4A. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, and it even suggests doing this. Then the sodium hydroxide in 2A and 5A, or 2, in my case, 2C and 5C. I can get this cap off. It's sealed. Scissors. So the sodium hydroxide, please be careful with that one. That is the most probably corrosive of all the chemicals in your kit. It's a strong base. Does not feel good if you have it sitting on your skin for a long period of time. Kind of feels slimy at first, then it starts to burn. So if you do get any on your skin, make sure you wash it off right away. This is one of the main reasons that you're wearing gloves. All right. So B, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sodium hydroxide might smell a little too, but it's not as bad as the ammonia. And last one, the dibasic sodium phosphate. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And last one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, one thing, if you ever notice a reaction start right away when you add the first chemical into one of your wells, it means it wasn't clean. Okay? So always keep an eye out for that. If that happens, try a different well, or you might have to redo that one after you've cleaned up. All right, so let's add copper sulfate. See what happens. So sodium chloride. We'll keep going until we get a reaction. 1, 2, 3, 4, 5, 6, So copper sulfate and sodium chloride. The very light blue got a little bit lighter blue because it got diluted by the sodium chloride, but I would not call that a chemical reaction. Let's see what happens to sodium hydroxide and copper sulfate. So here we have something that is lighter blue getting kind of darker blue. In this one, you might be able to see that it's a solid better if you have that hand lens handy, but it actually kind of looks like this chunky blue stuff, which means a precipitate formed. So we have a reaction, which means I will leave the other four up to your excitement to find out if a reaction occurs when you do it. Alrighty, so I'm going to set this off to the side. I'll clean it up once my recording's done. Let's start thinking about the lab report. Alright, so part 2, single displacement reactions. Here are the chemical formulas of the reactants for each reaction. So for each of the 4 single displacement reactions, describe what happened in each well. Chemical reaction occurred, write a balanced equation for it. Alright, you're going to be doing essentially the same thing for part 3 in question number 2. Right, you have the formulas of everything that was going on. In this one, you have to write double displacement reactions. Okay, so this is where being really good and strong with 1 polyatomic ion charges. All right, knowing that NO3 is a -1, SO4 is a 2-, etc., etc. Make that look like an actual 3. All right, there is a video recording on this. It's also going to be helpful if you are familiar with how the periodic table is set up. So, we have our 1A, 2A, our transition metals that make all sorts of funky One, 2, 3, 4, 5, 6. So transition metals make all sorts of strange ions, but our A groups have that pattern that we can follow. So remember, the goal is to get to 8, like all of the noble gases. The numbers on the group tell you how many valence electrons those atoms just naturally have. And then what they're going to do, they're either going to give up atoms to drop down to 8, or they're going to they're going to give up electrons to drop down to 8, or they're going to take them, and that depends on where they fall. 1A, 2A, and 3A all give up their electrons. So this one gives up 1 electron, making a +1, +2, +3 ion. All right. 4, you're never going to see anything in there because those can go either way. So honestly, those usually do covalent bonding. But then at 5A, instead of giving up 5 electrons, we're actually going to pick up 3 because we have 5, so we'll need 3 more to get to 8. So 3 extra electrons gives you a -3 charge. And then 6A picks up 2 for a -2 charge, and 7A picks up 1 for a -1 charge. Okay, so everything in this column makes a +1 ion. Everything in this column makes a +2 ion. Right? Always and forever. At least for this class. Okay? So, for example, in part 2, we had a reaction in the very first one. So we had zinc and copper sulfate. Now, the lab report gives me some formulas. So copper, according to what we're using in copper sulfate, it's a 2+ charge copper. All right, and then zinc is one of the very few transition metals that 99% of the time forms 1 ion. So it's usually 2+. All right, so in single displacement, you're going to have your metal plus a ionic compound, and the metal is going to kick out the cation on the ionic compound, giving you a new metal and a new compound. All right, so in this case, zinc and copper are going to switch, making copper plus zinc sulfate. Now, something we need to double check here is if zinc always forms a +2 ion, and we know sulfate's always 2 minus, we're fine not adding in any subscripts. Which also means overall our reaction is balanced. You won't always run into it being that way. Because, for example, if I switch over to part 3, we had our first reaction occur with, so here's part 3, and this is going to be a double displacement reaction, which means we have 2 compounds, 2 ionic compounds, and those are going to switch their cations, making AD plus CB. So we had NaOH plus CuSO4. Alright, we know sulfate makes a 2 minus charge. OH is another one of those polyatomic ions, always has a -1 charge. So we're going to have now afterwards NaSO4 plus CuOH. Now, I haven't added any subscripts on there, but we need to double check. Sodium always falls in group 1A, right? Which means it's going to form a +1 charge. And we know that sulfate is -2, which means we're going to need 2 sodiums to actually make that compound correct, to cancel out the charge. All right. CuSO4, the copper had to be +2 to cancel out with only 1 sulfate. So we know it's going to remain +2, and hydroxide is -1. All right, so this time we're going to need 2 hydroxides to cancel things out. And last but not least, we have 2 sodiums, 2 hydroxides, 1 sodium, 1 hydroxide. So we need to throw a coefficient 2 to balance our equation. Okay, if this stuff is challenging and you're not sure how to do it, you need to get help. This is chemistry. Balancing and writing equations, you need to be able to do this. And it is hard, right? Some people pick up on it really quickly. Some people, it takes a little while. If you're in that boat of it takes a little while, come get help. I would love to help. And good luck with the rest of the line.